Hello and welcome to Introduction to Artificial Intelligence course. My name is Marin Lujak and I will be your instructor in this course, whose material is a textbook called Artificial Intelligence, a Modern Approach by Stuart Russell and Peter Norvig. You can find a PDF version of this book online by searching it on the Google search engine. We are going to have in this course 5 sections. In section 1, we are going to deal with Introduction to Artificial Intelligence and the main concept of artificial intelligence, and these are intelligent agents and reasoning. In section 2, we are going to deal with formulating a problem of artificial intelligence, and basically we are going to deal with the complexity of the problem definitions, dividing every problem in tractable or intractable problem. Then section 3 is going to cover problem solving by search, and here we are going to concentrate on two kinds of search: uninformed search, where you have no a priori knowledge about the environment in which you work when you solve the problem, and informed search, and this is you have some kind of background information before starting to find the solution to your problem. And we are going to speak about heuristics, and in particular about A-star algorithm. In section 4, we are going to deal with artificial intelligence planning, and we are going to see the major concepts in artificial intelligence planning, covering basically situation calculus and the strips method. Section 5, we are going to deal with AI applications, and we are going to see basically the three major fields of artificial intelligence applications, and that is the robotics, intelligent transportation systems, and the factories of the future. We are going to review all the course and make the conclusions also in section 5. Now some practical issues about the course. So the prerequisites of this course are basic knowledge in discrete mathematics and algebra and introduction to programming. Without these basics, it's going to be difficult for you to follow the course. Regarding grading, your final grade is going to be composed of the forum participation, as long as we are doing this course only at My Learning Space and not in the class, and 70% is going to be your final exam, and 30% is going to be your forum participation. Each section is going to be detailed in My Learning Space, and at the end of each section you are going to have one forum where you are supposed to participate. Your forum participation will be given credit if and only if your questions are relevant and your responses to already given questions are correct. Okay, so why should we study artificial intelligence? You might have many different answers to this question, but some of them might be basically that AI is everywhere around us. So basically you can find it in industry, in science, in your appliances at home, on the computer, on internet, all the search engines that there are, in medicine, in game playing, spam filtering, logistics planning, robotics, machine translation. Artificial intelligence is everywhere. Okay, so it is an amazingly interesting study area, and it is a mix of many different research fields like philosophy, mathematics, economics, neuroscience, psychology, computer engineering, control theory, cybernetics, linguistics, and all these together. So you have seen AI robotics in all these areas that I have mentioned before, and you might have a bright career if you decide to study and work in the development of AI. So two possible categories of development of AI are in programming and engineering. So a proper coordination between these two leads to developing AI-enabled products like speech recognition technologies, robotics, game playing, spam filtering, and so on, the things that I've mentioned before. And the average package of an AI professional ranges between $100,000 and $150,000 in the United States. Companies like Amazon, Microsoft, Google, Nokia, and Sony, and other major companies in computer science and in technology are just a few companies that are recruiting AI talent. So AI jobs account for an average of 15 to 20% of jobs in most companies. And although they say that AI is going to replace a whopping 40% of blue collar as well as white collar jobs, it is also creating numerous job opportunities in as much as 130 to 140 million new roles in all sectors. Now let's tackle the major question at the beginning of the study of this beautiful science, and that is, what is artificial intelligence? There is no one single definition of artificial intelligence, and that is an issue even today. There are multiple definitions, and most of them are basically divided into categories. One category is referring to a human, and other category is referring to rational acting and thinking. So here in this table, you see four different categorizations. The categorization on the upper left corner refers to human thinking, so refers to the artificial intelligence systems that think like humans. In the lower left corner, you see the definitions referring to acting like humans. In the upper right corner, you see the definitions of the AI systems that think rationally. And in the lower right corner, you see the definitions of the systems that act rationally. Please read well these definitions and think about their differences and think about their common points. So referring to the AI capacities in relation to human thinking and acting, there is a natural question that arises, and that is, okay, how can we know whether an AI system can think or can act as a human? As we know, we humans are not perfect, so there is an important difference between rational thinking and rational acting, and human thinking and human acting. We are not always rational. Sometimes we are also influenced by emotions and by many other external or internal factors. So Alan Turing in 1950 proposed the Turing test that should be given to an AI system to pass the test regarding the capacity of the system to act as or think as human. The test was designed to provide a satisfactory operational definition of intelligence. So the concept was the following. You had a human interrogator on the left that you can see on the image, and there is a barrier between the human interrogator and a human on the right and the AI system on the right. This barrier is basically prohibiting that the human interrogator sees from the other side of the barrier. So the human interrogator only has a display on his or her computer where he or she can perceive the answers of the AI system and of the human that they send based on the inputs of the human interrogator given through the system, through the computer. Now, the question is, when does computer pass this test? So the computer passes this test if a human interrogator after posing some written questions, cannot tell whether the answer was given by a human or by the AI system. Regarding the capacities that this test would request of an AI system, we can mention some of them between others, and these are natural language processing, which basically is necessary to enable to communicate successfully in the language of interviews. So it might be or English or French, whatever language. Knowledge representation should be present in the AI system to store what this AI system perceives or knows of the environment. We would need also automated reasoning to use the stored information to answer questions and to draw new conclusions. And we would need machine learning to adapt to new circumstances and to detect and extrapolate patterns. Now, what do you think about the problems and limitations to the Turing test? Is this Turing test really capable of perceiving the human intelligence of AI system? Think about it and see if you can think of any weak points of this test. Now, Turing test deliberately avoided the direct physical interaction between the interrogator and the human and AI system on the right. This is why there was an extension of the Turing test, which was called total Turing test, in which they include video signals so that the interrogator can test the subject's perceptual abilities, as well as the opportunity for the interrogator to pass physical objects to the human on the right and to the AI system on the right, and therefore have some kind of physical interaction. So the characteristics that we described before of the AI system that would be required to pass this Turing test should be extended to computer vision. So you need to understand and perceive the environments through visual perception, and robotics. So you need also grippers and the actuators to interact with the environment. Now, there is a weak problem of the Turing test, and the problem is that it is not reproducible, it is not constructive and amenable to mathematical analysis. Therefore, it leaves the decision to the human interrogator, and basically it is not quantifiable, let's say. In addition to the characteristics that the AI system should have to pass the Turing test, we can also add motor control and all kinds of senses. Okay, so not only vision but also other senses, so audition, smell, touch, etc. So if we refer to an AI system in relation to thinking like a human, we must have some kind of determining how humans think. So this can be tackled by somehow getting inside the brain or human mind, and there are basically three ways to do this. The first one, you can go through introspection, and let's say you can self-introspect your thoughts and we can try to understand how we think. The second one is through psychological experiments, so observing people in action and finding cause reaction, basically connections. And the third one is through brain imaging while exposing people to different scenarios. So this is the case in cognitive science. So we observe the brain in action. while perceiving all the possible information from the brain, attaching it to different sensors. So what is a cognitive science? A cognitive science is an interdisciplinary field that brings together computer models from artificial intelligence and experimental techniques from psychology to construct precise and testable theories of the human mind. Now, regarding thinking rationally, we might say that the father of the rational thinking or logic was Aristotle, who especially worked on whose works basically contain the earliest formal study of logic that we have. So he worked on irrefutable reasoning processes or right thinking, and he defined the syllogisms. So a syllogism is a form of deductive reasoning where you arrive at a specific conclusion by examining two other premises or ideas. So his syllogisms provided patterns for argument structures that always yielded correct conclusions when given correct premises. I will give an example. So for example, Socrates is a man, all men are mortal, therefore Socrates is mortal. So these laws of thought were supposed to govern the operation of the mind, and their study initiated in a field called logic. By 1965, programs existed that could in principle solve any solvable problem described in logical notation. However, two problems with this kind of approach is that first, it's not easy to take informal knowledge and state it in the formal terms required by logical notation. And second, there is a big difference between solving a problem in theory, in a principle. It is a usually very simple laboratory problem, and solving a problem in practice, where usually these practical problems are much larger than the laboratory problems, and therefore just with a few hundred facts you can already have the exhaustion of the computational resources of any computer, unless it has some guidance as to which reasoning steps to try first. So basically logic is limited in still today on resolving real world problems. Rational acting is about rational agents. Now let's see what rational agent is. So a rational agent is one that acts so as to achieve the best outcome or the best expected outcome if there is an uncertainty about the possible solutions of the actions. We are mentioning here the keyword agent. So what is an agent? We are going to deal with this concept later on. For now, let's just say that it is something that acts, perceives its environment, acts on its environment based on the perception, and has some kind of decision making to differentiate between different actions. Agents can operate autonomously, they can perceive their environment, they can persist over a prolonged period of time, they adapt to change and create and pursue goals. So an agent is one of the main concepts of artificial intelligence. And the rational agent basically does all of these things, but maximizing its utility. Usually it is a utility function. Now, regarding this concept and the way of seeing artificial intelligence through acting rationally, it is important to say that it is more general than the laws of thought, because correct inference is just one of several possible mechanisms for achieving rationality. And the standard of rationality is mathematically well defined and completely general, and can be unpacked to generate agent designs that probably achieve it. So we are going to study different agent designs also in this course. So in this course, we concentrate on general principles of rational agents and on components for constructing them. And we are basically going to study all kinds and architecture of rational agents with the focus on utility functions, on maximizing the utility and maximizing the goal achievement. So which tasks require artificial intelligence? Let's sum up all the things that we have said so far. So artificial intelligence is the science and engineering of making intelligent machines which can perform tasks that require intelligence when performed by humans. And could you give me some examples of the tasks that require AI? Here are some: solving a differential equation, brain surgery, inventing stuff, playing Jeopardy, playing Wheel of Fortune. What about walking? Do you need artificial intelligence for walking? Or about grabbing stuff? What about pulling your hand away from a fire? Is the intelligence needed to do that? What about watching TV? Getting the information from the TV to your brain and memorizing it? Do you need an intelligence to do that? What about daydreaming? When you just go away in your brain somewhere else, physically being here, but mentally being somewhere else. Do you need intelligence to do that? Now, how to achieve artificial intelligence? And how is artificial intelligence research done? There are two parts of artificial intelligence research, and there is a theoretical part and the experimental part. The experimental part has both basic theory and applied aspects. And there are two main lines of research, basically the biological one and the phenomenal one. And the biological one basically researches a human because human intelligence is the reference point here. So we should study humans and imitate their psychology and physiology in this biological part. The biological part also does not only study human, but it also studies animals and insects, and it tries to imitate the behavior and the concepts of the nature in the biological sense. And then there is the phenomenal part, which is based only on studying and formalizing common sense facts about the world. This also studies the problems that the world presents to the achievement of goals. So basically here, instead of looking how an actor, a biological actor, does things, we are just looking at the laws of the nature and trying to understand the connection between cause and the effect. These two approaches interact to some extent, and both should eventually succeed, but Professor John McCarthy is convinced that it is a race, but both racers seem to be